Hi engineering Janta, I am Vaibhav Shukla and today we'll be dealing with the min stack problem or the minimum stack problem. What is it all about? What this problem statement is, how to solve it, approach, everything we will discuss in detail. Fine. So this is another video in the free DSA series that we are building for you so that you thrive high in your career. Fine. So before I dive in deep, go ahead, follow the daily ritual and follow us on these social media handles so that you never miss any hiring update. Also, top 3 comments get a chance to win the Prep Insta Prime subscription for free. So do not miss out on that chance. Fine. So let's understand the problem statement. You have to design a stack that supports push, pop, top and retrieving the minimum element in constant time. Now, the challenge is that you have to build these functions push, pop, top, fine, and alongside them you have to retrieve the minimum element from the array, from the stack, fine. So from the stack you have to retrieve the minimum element. This is the basic given agenda to you. Now you have to implement this in constant time, which basically means order of 1, fine. So for the order of 1, for the constant time complexity, you have to do it. And what you have to do basically is that you implement a min stack class which initializes stack object. You create a push function which pushes the element val onto the stack. You create a pop function which removes the element on the top of the stack. You create a top function which gets the top of the stack. And then you create a getMin function that retrieves the minimum element in the stack. All this, how to implement, you have a basic idea. Still, we'll understand that there are a few minor tweaks that we need to do in this particular problem to solve it in the push pop functions as well. So it is clearly written, you must implement a solution with order of 1 time complexity with each function. Fine. So I'll go ahead and let's understand the problem statement more deeply. What is it is saying? So it's basically saying that whenever you push any element in the stack, retrieve the minimum element for me. For example, just leave this example for a while. One example I am giving, then we will discuss this example. Fine. So say that you tried pushing this element 1, fine, then you pushed 2, then you pushed 3. Now if you know that minimum element when I pushed 2 was 1, when I pushed 3 was 1, then I pushed minus 1, and in this case when I pushed minus 1, in this case minus 1 is the minimum element. Now what you can do, how you can retrieve the minimum element, because this is representing the top of the stack. For example, if I put 4 here, then top of the stack is 4, but the minimum element is minus 1 only. So how many variables will you keep? Because to keep a track of it, you need to either keep minimum variable of 1, minimum variable from 2, minimum variable from 3. Like this you cannot do this, fine. You cannot do n comparisons because we need to implement in order of 1, isn't it? That is the real challenge. इसमें असली challenge ही यही है. एक दफा सोच के देखो, थोड़ा सा दिमाग से ऐसा सोचो. If you want to keep a track of minimum element, then for every element that you are pushing, you will have to create a variable which will store the minimum element than that. या तो ये एक तरीका हो, या फिर दूसरा तरीका क्या है, मैं मिनिमम एलिमेंट को स्टोर करता जाऊं वेरिएबल्स के अलावा. अगर वेरिएबल्स में नहीं स्टोर कर पा रहा हूं तो देयर इज अ चांस दैट आई हैव टू डू एन ट्रैवर्सल्स. मुझे एन ट्रैवर्सल्स करने पड़ेंगे, मतलब पूरा ट्रैवर्स करूं मैं, एन कंपैरिजंस करूं, वो भी पॉसिबल नहीं है यार. थोड़ा इट साउंड्स स्ट्रेंज टू डू सो because I have to solve it in constant time complexity. So what I can do is, if this is my stack, fine, I create another stack, fine, this is another stack. Now when I pushed 1, I pushed the minimum element here, fine, this is my minimum stack, fine, this, or I can call it min stack, fine. Now when I push 2, I again checked which is the minimum element. So for this 2, again 1 is the minimum element, I again pushed 1. Now for 3, I checked which is the minimum element, again it was 1. So it was 1. Now all I need to do while retrieving the minimum element is, for the index that I am checking, for example, if I pop, I'll explain you, just wait for a while. Let me further add on things. Now when I push -1, what is the minimum element? -1. So for this, -1. When I push 4, what is the minimum element? -1. Now when I pop one element out of them, fine, say I, first of all I checked that what is the minimum element. Now if I check minimum element till here, for example, if I check minimum element till here, what will happen? This particular value is the min value. You know that this is the minimum element. Fine. Say I pop it out. Fine. I pop that out and I pop the corresponding minimum value as well. Now, if I try checking till this, that for this particular stack that I am having right now, when I popped the top element and the new top is -1. Now out of these 4, which is the minimum element? Without any comparison, I can straight away say that the corresponding minimum is -1. Now when I further pop it, I pop this as well. Fine. Now for out of these 3 elements, I need to say which is the minimum element without any extra comparison. Just with the constant time complexity, what I can do is fetch the same element from the min stack, the element at the same index from the min stack corresponding to the upper stack, isn't it? इसका corresponding element निकाल लो min stack से, minimum element होगा. One comparison, constant time complexity, no big issue. Fine. So you can implement it using 2 stacks. Fine. This is called a 2-stack approach. There can be other approach and that would be a homework, but this is one of the finest approaches that can be used. Fine. So in this order of the approach that we'll discuss further in the code implementation, this approach is of order of 1 time complexity and order of n space complexity. Fine. So what I do is I initialize a min stack, I push a few values, so null will get pushed, then again I push a few values, so output comes like this. Fine. Null, 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 -3 and then null and then 0 and then -2. Such output should come for these operations with this input of stack. Fine. Now we'll understand the code portion, which will explain us better how it happens. Let's go to code portion. When I come to the code portion, simple है, इस example को reference रखो. Fine. Keep this example as the reference. ये अपने आप solve हो जाएगा. ये अपने आप solve हो जाएगा. Keep this example as the reference. Also, you can find this problem in our top 150 not out list. You will find the link in the description. उसमें check कर सकते हो. Secondly, this is also one of the most famous problem. Min stack is one of the most famous problems. Fine. So you might find this in interview as well. So look closely when I'll discuss the code portion. Now you declare, this is the C++ code. You declare a min stack class. You declare a stack and a min stack. So basically you declare 2 stacks. Fine. Both of integer types. Now this is the basic constructor. Fine. Now I go ahead and declare the push function. I basically define the push function here itself. I'll tell you what this push function is doing. So you have an integer val, say we had 2. Fine. So what this val will do, first of all, in this stack, in this particular stack, this is the data type of the stack or the standard type that we use, the standard type of stacks that we use in C++ using standard libraries. So this is one particular stack, min stack is the second stack. So I have 2 stacks here. I should rather draw it for better clarity. So this is min stack and this is stack. Fine. So the first thing that you do in the push function that we are creating is that if I have this 2 as the value, fine, 2 is given here, passed here as a parameter. First thing you do is you push the stack, you push this value in the stack. See here, I push it here, as simple as that. Then you create another variable. Basically you use the same type of variable to update it out. Fine, you can create another variable, but generally this is a good practice to use this variable for the further updations. Now I use the val variable, what I do is, using the standard library, what I do in C++, I take the minimum. Min function is a predefined function in C++, which returns you the minimum value out of the two values that you pass to it. Basically, min works like this: value 1, value 2. Fine. So out of these value 1 and value 2, whichever would be minimum, min would pass it. Fine. Min would return it. Simple. Fine. So in this case, one value is VAL, which is nothing but 2. Now, this statement checks if min stack is empty. That is why there is conditional operator. If min stack is empty, then you need not to check further. If this comes true, then you will simply go ahead and push this particular value which is passed here. Now, if the min stack is not empty, basically if this particular stack is empty, this min will simply return the value of this VAL. Fine. As simple as that. It would simply return the 2. But had there been any other element, which we will do right now, I'll show you how it happens. Had there been any other element, it would have behaved differently. Fine. So right now, it goes ahead and it assigns first of all 2 to the VAL again, and then it pushes to the min stack the same value. So I have 2 here. Fine. Now, when I try pushing another type of value, fine. Now I'll push another value. For example, I say first of all 2 was pushed. Now I push 3. Now when I push 3, now carefully see, 3 is being passed here. First thing is push the 3 in stack. So in my stack, I push 3. Now I check, again I go through this statement. Min checks for 3, and first of all it checks is min stack empty. So min stack is not empty right now. So for the second value, I told you this, that min function works like this: min val 1 and val 2. So here val 1 is 3, value 2 is min stack dot top. If you can see here, value is min stack dot top. So min stack ka top 2 hai. Simple. You return it here. Fine. So basically now comparison would happen out of 3 and 2, and whatever comes out as minimum, min will return that. Out of them 2 is the minimum, so min will return 2. So VAL, now after this comparison, VAL becomes equal to 2, because out of them, out of 3 and 2, this would say that 2 should be compared with 3. Out of 3 and 2, 2 is minimum. Minimum is passed here. Fine. The minimum value, which is 2, is passed here, stored in VAL. Now I push 2 in the min stack. Fine. So again here 2 is passed. Now for corresponding 3, you know that minimum element is 2 without any comparison. Clear? Things are already being sorted here, already being done here. Fine. Now you are getting the hang of things, how this problem is being solved. Now if I go ahead for -1, now when I go ahead for -1 and I start pushing -1 here, fine, I start pushing -1 here. In this case, what will happen? First of all, -1 would be pushed here. This statement executes. Then out of val, which is -1, and out of the top of the stack of this particular stack, min stack ka top, it is 2. So out of them, if I compare the minimum out of them, it is -1. VAL will get -1 as the value returned by this particular function. Min stack में क्या push करेंगे? -1. Now -1 would be pushed in the min stack. Fine. So if that happens, again my -1 is not being written beautifully, so I would write it beautifully here. Wait. Wow, wonderful. Now I like it. So in this case, again -1 gets pushed here. Fine. Now out of these 3, you can straight away tell that top of the min stack would return me the minimum value. Simple. Now if I go further, now things become simple. I'll come to pop function later. First of all, I'll explain you getMin. So it is very simple. I am returning the top of the min stack. Very simple. For the top function, return stack.top. Fine. So whenever I ask for top, return the top of this particular stack. When I ask for the top of min stack, basically when I ask for the minimum element, return the top of min stack. So basically top of this element or this stack, fine, top of min stack is the minimum value. Fine. So this is the minimum value. Top of the min stack is minimum value. Now let's come to the pop. Fine. So what will pop do? Whenever pop happens, pop should happen simultaneously from both stacks. So if I am popping out one element from our stack, which is the primary stack or the main stack, then you must pop the corresponding minimum element from the min stack. I'll show you what I'm saying. I have shown you earlier, but still again we'll see. Whenever pop happens from here, for example, pop, I pop it out, fine. As soon as I pop it out, this must be popped out. This must be popped out. Why? Because when later on I'll check this stack, out of them minimum would be 2, right? But here min stack is returning me -1. So whenever I pop out some element, I must pop out its corresponding minimum as well. Fine. So whenever pop happens from both stacks. Fine. Pop should happen from both stacks. Now when pop happens from both stack, the problem that is solved is that whenever I'll again ask for the getMin, whenever I ask again that give me the minimum element, then it would return the top of this min stack, which is 2. If I check it in the primary stack or the stack that I declared initially, in this I am having 2 as my minimum element, which is true, isn't it? Out of these 2 is the minimum, no? And the min stack is having 2 on its top. So it is correctly done. Problem आसान है, but इसका approach सोचना मुश्किल है. Fine. This is a very easy problem. However, LeetCode rates it as a medium level problem. Let me tell you, this is rated as a medium level problem on LeetCode. Fine. But if you know how to approach this problem, this is super simple. If you don't know the approach to this problem will torment your brain to next level. Fine. So this is all about this problem. I hope there's no doubt in it. But if there is any doubt, go ahead, tell me in the comment section. Also in the comment section, you tell me whatever brute force method you could apply on it. Whatever method apart from this you could think of to implement this problem or to solve this problem, you tell me in the comment section. I'll check it out, because top 3 comments can stand a chance to win Prep Insta Prime subscription for free for 3 months. So that is another golden opportunity that you might have after commenting. Fine. So that's all for today's problem. Keep doing good for others. Good will come back to you. Fine. So go ahead, keep practicing and keep working here. If you correctly see, minstack.pop happened in the end. Fine. So for those who are watching till the end, such tidbits are very valuable. Fine. So go ahead, keep practicing. All the best. Thank you.